Hello again. So today we're doing 4.1 day 1, finding and interpreting slope of lines. There's no warm-up for this one. So for our first example, they give us a table and then we're going to graph some things. So it says, if you leave home and walk a given distance at a steady pace, your distance, d feet, from home is directly proportional to time x minutes you walk. So all that's saying is we're walking at a steady pace from our house to some destination, and that is directly proportional. Okay? You can use a table, which they give us here, and a graph to represent the proportional relationship. So basically, I'm going to graph this line. Okay? From the table, you can see the constant proportionality is 250. Okay? So if I look at this, I'm going to graph this. This information. So really this is like my x coordinates and my y coordinates, okay? And I'm giving time is x minutes and distance from home is d feet. And at 1 minute I've gone 250 feet, at 2 minutes 500 feet, 3 minutes 750 feet, 4 is 1,000, 5 is 1,250, okay? So I've plotted this on my graph in case you can't see my numbers here. All I've done is put 1, 2, 3, 4, 5, which was the x values in my table here. And then I put 250, 500, 750, 1,000, 1,250. So it's an increase of 250 every time. And this is technically 0 here. Okay. So if I look at my chart, at 1 minute, I'm at 250. So that's my first point. At 2, I'm at 500. 3, I'm at 750. I can zoom out here now for you. 4, I'm at 1,000, and 5, I'm at 1,250. So I'm going to take my handy straight edge here and just connect those points. And I would keep going at that pace, seemingly forever. Obviously, eventually you'd probably get tired and would stop walking at that pace, but in this case, we're going to say it goes on forever. Okay. So all this is saying is my line here, I'm going at a nice steady pace of 250 feet per minute. Okay, so my slope in this case would be, I'm going 250 feet per 1 minute. Because I'm going up 200, then over 1, up 250 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 over 1. Okay, so this is minutes, sorry. Okay, so I'd have 250 feet per minute, and 250 over 1 is just 250. Okay, and usually you would label that feet per minute. Okay, feet per m. All right, so that's what we're looking at there. So that's my slope of this wonderful line here. Okay, so we're going to talk more about slope, but this is just kind of to help you look at it and see it a little bit. Okay. So a note that you have in your notes is that slope is the rise over the run. So when we did this, I said we went 250 feet every minute. So we went 250 over 1. So slope is rise over run. And all that is the change in y's over the change in x's. Okay? That's what this subtraction is saying. Now this part of the equation is going to come in the next section, okay, where we're actually going to use this formula. But today we're just using basic ones, okay? But this is something you need to understand for the rest of the chapter. Okay? All right, so I have 2 examples now, and it just says, find the slope of the following lines. So when you want to find the slope and you have a graph, the easiest way is to pick 2 points. And you can see on my graph I have 2 plotted. So you might want to take a second to actually plot this graph because I gave you a blank graph. Notice I have just 1, 2, 3, 4, 1, 2, 3, 4, 5 labeled, 0, -1, -2, -3, all these numbers, okay? And my first point is at -2, -1. And then my second point was 2, 4. So go ahead and plot those points so you can see what I wrote. And then draw a line between them. Okay, so pause the video at this point. I'm going to keep going though. So when you want to find a slope using a graph, you look for 2 distinct points, okay, that clearly cross one of the intersections, okay? And I have mine labeled nicely for you. And then remember, slope is rise over run. Okay, and rising is up and down, run is left to right. Okay, so I'm going up from this point to this point 1, 2, 3, 4, 5 places. So my rise is 5 spots. Okay, my run is 1, 2, 3, 4. Okay, and since this one went up, it's positive, and since this one went to the right, it's also positive. If I had gone down or into the left direction, these would have also been negative. Okay, so my slope in this case is just 5/4. Now, if you can simplify this fraction, you always should. Okay, it's okay completely if it's an improper fraction as well, and as is this case. Okay. So go ahead and pause if you need to catch up. I'm going to move on to my second graph here. So again, I'll give you a second to plot these points. This one is 1, -1. You just can't see that. And this one is -3, 3. Right? So plot those 2 points. 1, -1, -3, 3. And then draw a line between them. Pause if you need to. I'm going to keep going. So again, slope, that's what I'm trying to find here. Rise over run equals. So again, my rise is my y. So 1, 2, 3, 4. So I've gone up 4 spots. Now I'm going to the left 1, 2, 3, 4. So that's going to be -4. Okay, because I moved in the negative direction, I make that negative. Okay. Now if I keep looking at this, usually you write the negative on the outside of the fraction, or with the top, it doesn't matter. And then 4/4 reduces to -1. And you can kind of see there's a point here, and then here, and then here. So it could be over 1, up 1, over, or up 1, over 1, up 1, over 1, up 1, over 1 every time. So it makes sense that this reduces to -1. Okay. Now another thing they might ask you, if I look at both of these graphs, notice how they have very different lines. This one's going in this direction, this one's going now this direction. So when you see a line going like this is called a positive slope. Okay, which makes sense because my slope is positive, right? If I look at this one, when it's facing this way, it's called a negative slope. Which again makes total sense because my answer here was negative. Okay, so when you have, if I get my answer and it's negative, I know it's a negative slope, but you can also tell by the shape of the graph. So if you're ever worried and you're like, oh, am I going to get a positive answer or a negative answer? You can look at the shape of the graph. If it's going this type of way, even no matter where it is on the graph, as long as it's facing this way, it's positive, and here it's negative. You know, no matter where it is on the graph, as long as it's like this. Okay, even if it was tilted a little more. Okay, so we have positive and negative slopes. We're going to talk about 2 different types of slope in the next section, but we're not going to get quite to that today. Okay. All right, let's move on to the next example here. So we have lots of instructions here. It says a red car and a blue car leave the same garage at the same time. Each driver drives at a steady rate. Okay, so all that means is they're going, whatever, 40 miles an hour for the whole time. They're not changing their speed. The graph represents the distance d miles traveled by the red car over time. Okay, so they've given me a graph for the red car, and I'll zoom in and show you where all that is. The blue car, it tells me, they don't give me a graph for this one in the book. It says traveled at 40 miles over the same length of time. Okay, so let's look at the graph of the red car. And their question is, at what speed is each car traveling? Okay. So basically you're finding the slope. So if I look at this, my x is my time, okay, my x-axis I should say, and my y is the distance traveled. Okay, so this is at time 1 minute, or I'm sorry, hours, 1 hour, 2 hour, 3 hour, 4 hour. This is at 50 miles, 100 miles, 150 miles. Okay, and we have the point 0, 0, and 4, 150. Okay, so basically to figure out how fast they're going, I want to find the slope. Okay, so from 0, 0 to 4, 150, I'm going up 1, 2, 3 spots, right? But really, not just 3 spots, I've gone up 50, then 100, then 150. So I have to look at what my time is on this, okay? I can't just assume it's 3 places, okay? So be very careful on labeling. So my slope here, sorry, my homework problems are kind of in the way, is 150 over, now this is 1, 2, 3, 4, so I can actually count the spots. 1, 2, 3, 4, okay? 150 over 4, which I can reduce. Oop, you guys can't see that. Okay. So the slope is just 150 over 4, rise over run. Okay, and then I can reduce that, okay? Now, if you're just thinking off into the top of your head, you can do it however you want, or you can use a calculator if you so desire. So I'm just doing my math off to the side here, 4 into 150, if you'd like to see that. 4 goes in 3 times, that's 12. Subtract that, that's 30. So it's not evenly going to go in. So I would just reduce this and say 125 over 2, okay, which would be my simplest form. So that's how fast that car is going. Now, I know I traveled for 4 hours in the red car, okay, to get my 150 miles. It says the blue car traveled 140 miles over the same length. So if I really wanted to graph this and have a similar graph here, okay, I have my 50, 100, and 150. So 140 is going to go just below 150 at the 4 hours, and then I can connect the 2 dots again. I was naughty and didn't use a straight edge, but that's okay. So my slope, remember this is 140, or 4, 140. Okay. So my rise, I would go up 140 spots over the same 4 hours here. Okay. Again, I'm sorry, I keep zooming in and out, I forget. Okay. So that would be 70 over 2, which would be 35. Okay. So this is my final slope, the reduced form. But if I wanted to compare which one was going faster, this one goes 140 miles in 4 hours, and this goes 150 in 4 hours. So this, the blue car, is faster in this case. Okay, that's not what they were asking. They just want to know at what speed each one was going. But, you know, this works out. Okay, so just another question to think of. Now, your homework is going to be 1, 2, and 5 on page 148. I know there's an even one in there, so you can ask me for some help and check that if you want. And then I'm going to give you a worksheet with some extra problems, okay? So you can get some more practice, since that's only 3 problems. That's not a lot. Okay? And we will see you later for 4.1 day 2. Have a great day.